The number of birds of a certain species in a forested region is recorded over several years. At time t-years, the number of birds is n, where n is treated as a continuous variable. The variation of the number of birds is modeled by the. It is given that n equals to 320 equals to 0. Find an expression for n in terms of t. So we have to solve the differential equation dn over dt equals to n 1800 minus n over 3600. So we can do the separating variable first. We put n on the left side. So it will be 1 over n 1800 minus n dn dt equals to 1 over 3600. So this form is the third form. If we have fy dy dt equals to k. So we can now integrate both sides with respect to t. And then we have integral 1 over n dn equals to integral 1 over 3600 dt. The term on the right side will be easy because it's only 1 over 3600 t plus c. But for the left part, we have to solve this using the partial fraction. So I change the term into partial fractions, a over n plus b over 1800 minus n. And then I do the cross multiply, a times 1800 minus n plus b times n over n equals to 1 over n 1800 minus n. Because the denominator is the same, so I can just equalize the numerator. So 1 equals to a plus b n. So when n equals to 0, I will have 1 equals to 1800a. So a equals to 1 over 1800. When x equals to 1800, I will have y equals to 1800b. So b is 1 over 1800. So I can just replace into 1000, 1 over, yeah? 1 over 1800 n plus 1 over 1800 minus n. So I can convert this into, I can factorize the 1 over 1800. So 1 over 1800, 1 over n plus 1 over 1800 minus n dn. And then I can multiply the 1800 to the right. So integral 1 over n plus 1 over minus n, dn equals to over 3600 t plus c. So this is become 1 over 2. And then now the left hand side can be integrated into ln n plus ln 1800 minus n divided by minus 1. Yeah, don't forget to divide by the negative, the derivative of this. Equals to 1 over 2t plus c. So ln n minus ln 1800 minus n equals to half t plus c. I can simplify this. Ln minus ln is ln n over this absolute of t plus c. So we can find the c first. When t 0, we put the information. When t 0, n is 300. So ln 300, 1800 minus 300 equals to 1 over 2, 0 plus c. So this is ln 1 over 5 equals to c. So the full equation will be ln n 1800 minus n equals to half t plus ln 1 over 5. But we can't stop until here because we have to express n in terms of t. So I can combine the ln, become ln n 1800 minus n minus ln 1 over 5 equals to half t. So ln minus ln again, so it's divide. So it will become ln 5n 1800 minus n. Yeah, because I divide by 1 over 5, so I multiply by 5. Equals to 1 over 2t. And we can remove the ln by using the e to the power of half t. So 5 over m, this one, and then we make n as the subject. So 5n equals to e half t minus n e half t. So 5m plus n e half t equals to e half t. So n 5 plus e half t equals to 1800 e half t. So n equals to e half t over 5 plus e half t. And then we have to multiply by e minus half t over e minus half t to remove the e on the numerator. So we can answer question B later on. So from this, I can have, I move it here, n is equals to 1800 times 1, yeah, e half t minus e half times e minus half t equals to 1 over 5e minus half t plus 1. So this is the expression. And then the question B, according to this model, how many birds will there after a long time? So the second question, when after a long time means t is approaching to the infinite. So if we express our answer in this form, we can answer this question easily. So we can just put it n 1800 over 5 e to the power of negative infinite, replace the t by the infinity, plus 1. E to the power of negative infinite is equal to 0. Yeah, approximately 0. So equals to 0 plus 1. So it's 1800. That's number 1. 2. A model for the height method of a certain type of tree times at time t years after being planted assumes that while the tree is growing, the rate increase of the height is proportional to 9 minus h 1/3. Given that t equals to 0, h equals to 1, and dh dt equals to 0.2. Show that satisfy the differential equation. Okay, this question is the type of question that we have to construct the differential equation. So we can construct the expression using the information from the question. It says that the rate of increase of the height is proportional. So the rate of increase of the height is the h over dt proportional to 9 minus h to the power of 1/3. To change the proportionality sign into equal, we have to multiply the expression by a constant, 9 minus h 1 over 3. By multiplying it with a constant, so we have changed the proportionality into the equality. Now we have to solve this. And then we have to show that the differential equation will be in this form. So we can replace the information first when h equals to 1, the h dt is equals to 0, 2. So 0, 2 equals to k times 9 minus 1, 1/3. So 0.2 is k times 8, 1/3. So this is 2. K is 0.1. So that means the h dt will be equals to 0.1, 9 minus h to the power of 1/3. Okay, sure. That's for the first one. For the second one, solve. Obtain expression for h in terms of t. Now we solve this differential equation. So since we have h on the right side and dh on the left side, so we have to move h to the left side. So it will become 1 over 9 minus h, 1 over 3, dh dt equals to 0.1. So this again the type of number 3. So we can integrate both sides with respect to t. And I can simplify this one, 9 minus h to the power of negative 1/3 dh, 0.1 integral dt. On the right side, it will be easy because 0.1 t plus c. But on the left side, we have 9 minus h to the power of with plus 1. So it's 2 over 3 and 3 over 2. And don't forget to divide by the negative 1. So it's negative 3 over 2, 9 minus h 2 over 3 equals to 0.1 t per c. So I just multiply it with the negative 2 over 3 to remove the coefficient here. So it will become 9 minus h 2 over 3 equals to minus 0.1 times 2 over 3 is 0.2 over 3, so 2 over 30 plus c. Yeah, when c is multiplied with the 2 over negative 2 over 3, it will still c because c is an arbitrary constant. Yeah, so it doesn't change into negative 2 over 3 c. So I can simplify this 15, yeah, 1 over 15. So 9 minus h to the power of 2 over 3 equals to negative 1 over 15 t plus c. And then we can just put again the information when t 0, the h is 1. So 9 minus 1, 2 over 3 equals to 0 plus c. So we can find c. So this is 4 equals to c. So the equation will be 9 minus h to the power of 2 over 3 equals to minus 1 over 15t plus 4. Or I can rewrite as I remove the power. So minus 1 over 15t plus 4 to the power of 3 over 2. So height will be 9 minus the square root of 4 minus 1 over 15t cubed. This is the expression. And then the third one, find the maximum height of the tree and time taken to reach this height after planting. If we see from the equation, this value will maximize at this value will be minimized when t goes to infinite. So that means this value will become 0. So the maximum height will be equals to 9. And this will happen this value can be maximum if this term is equals to 0. And it cannot be exceed the 9 because the number of the square root cannot be negative. So that means the maximum height will be equals to 9. And this will be happen when the term inside the square root is equals to 0. So 4 minus 1 over 15t equals to 0. So 1 over 15t equals to 4, t equals to 60 years. By V, calculate the time taken to reach half of the maximum height. So we can just put it into the formula. It's equals to 9 minus the cube root, the square root of 4 minus 1 over 15t cubed, and put it as the 9 over 2, yeah, the half of the maximum height, equals to 9 minus this. So this one is 9 over 2 equals to 4 minus 1 over 15t to the power of 3 over 2. So from here, we can use the calculator to find the t. 9 over 2. And then to the power of 2 over 3 equals to 4 minus 1 over 15t. So that means 1 over 15 t equals to 4 minus 9 over 2, 2 over 3. So t equals to 4 minus the answer. And then multiplied by 15. So 19.1 years. 3. In a certain industrial process, the substance is being produced in the container. The mass of the substance in the container 10 minutes after the start of the process is x at any time. The rate of formation of the substance is proportional to its mass. Now, from this work, we can construct the differential equation. Also, throughout the process, the substance is removed from the container at a constant rate of 25 grams per minute. When T0x is equals to 1000 and dx dt equals to 75, show that x and t satisfy the differential equation. So we have to construct again. So from the word that proportional, so I can write as the rate of formation of the substance is proportional to its mass. So we say that the mass is x. So the rate of formation, so the x dt, proportional to its mass. So proportional to x. But at the same time, the substance is removed at a constant rate of 25 grams per minute. So that means I can say that there is a amount that is being removed at the constant speed of 25. And we have to combine these two. So I can combine, I can change the first one into the equation equals to, we multiply by the constant to change the proportional into the equation. So k times x and dx dt equals to 25. So to combine this, dx dt will be k equals to kx minus 25 because this is removed. So I have to put minus, so better to put negative here and negative here. Now we have to find the value of k. Okay, using the informations, the dx dt is 75. K times x is 1000 minus 25. So 1000 k equals to 100, so k equals to 0.1. So I can replace the x dt equals to 0.1x minus 25, and then I can factorize x minus 250. So that's for the first one. And then we have to solve this expression for x in terms of t. So we move again the x to the left side. So it's 1 over x minus 250 dx dt 0.1. So we integrate both sides with respect to dt. So integral 1 over x minus 250 dx equals to 0.1 integral dt. And this will become ln x minus 250 equals to 0.1 t plus c. So find c using the information t0 x equals to 1000. So ln 1000 minus 250 equals to 0.10 plus c. The t is 0. Yeah. So that means c is ln 750. So the equation ln x minus 250 equals to 0.1 t plus ln 750. And then I have to make x as a subject, so I have to combine the ln minus ln 750, 0.1 t. So ln minus ln become ln of 750, 0.1 t. And then remove the ln by e to the power. So x minus 250 over 750 is e to the power of negative of 0.1 t. And then we only have one x here, so it will be easier, yeah? So x minus 250 equals to 750 e 0.1 t. So x equals to 250 plus 750 e 0.1 t. So this is the final expression. A certain curve is such that its gradient at a point is proportional to x, y. So we have to construct again the differential equation. At the point 1, 2, the gradient is 4. So the gradient is the dy dx. So dy dx is proportional to xy. So I can change again into equals to k xy. And then to find the k, I can put the information. So the gradient is 4, k times 1 times 2. So k equals to 2. So the equations will be dy dx equals to 2xy. And then I have to, by setting up the and solving the differential equation, show that the equation curve will be this. So I have to solve this. We have y here and dy here, so I have to move y to the left. So it's 1 over y dy dx equals to 2x. And then I do integration with respect to x. So integral of 1 over y dy equals to 2 integral x dx. And this is equals to ln y equals to x squared plus c. So I can just remove the ln y equals to e to the power of x squared plus c. This is e x squared times e c. So this is another constant, a e x squared. Y equals to a e x squared. And then I have to find the a. A is, I can put the coordinate 1 and 2. So 2 equals to a e to the power of 1. So A is equals to 2 over E. So the expression will be y equals to 2 over E, EX squared, or 2E x squared minus 1. Shown, yeah? And then for the II, state the gradient of the curve at the point -1, 2 and sketch the curve. So we can find the gradient. So dy dx equals to 2xy. So we can put 2 times -1 times 2. So it's -4. And sketch the curve. So I have 1, 2, -1, -2. So 1, 2, 1. I have 1 and 2 from the equation, and then -1 and 2 from the equation. It says that the gradient is +4 at 1, 2 and -4 at -1, 2. So from the equation, we can see that it will be increasing. So like this, if I put x equals to 0, 2e to the power of 0 minus 1. So e 2 over e. So it will be 2 over e. So from here, and then it will be increased. So this is the tangent will be positive. And for -1, 2, the gradient will be negative. So for x negative, it will be also positive. So it will be like this. So this is the sketch. In a chemical reaction, a compound X is formed from two compounds Y and Z. The masses in gram of X, Y, Z represents at the time t seconds after the start of the reaction are X, 10 minus X, and 20 minus X respectively. At any time, the rate of formation of X is proportional to the product of the masses of Y and Z. So we highlight this proportional. So at any time, it's proportional to the product of the mass Y and Z. So later on, we will have to multiply the mass of Y and the mass of Z. When t is 0, x equals to 0, and dx dt equals to 2. Show that x and t satisfy the differential equation. Okay, so we can take the word from this sentence. At any time, the rate of formation of x. So the mass of x is x. That means the x dt will be proportional to the product of y and z. So it's 10 minus x and 20 minus x. And then we have to change into the equation. So k times 10 minus x, 20 minus x. Now we have to find the k. We put the information 20, 0, x 0, and the x dt is 2. So 2 equals to k times 10 minus 0, 20 minus 0. So 2 equals to 200k. So k equals to 0, 0, 1. So for the first one, dx dt is equals to 0, 0, 1 times 10 minus x times 20 minus x. Shown, yeah? Second, solve this differential equation and obtain an expression for x in terms of t. So we solve this, we see that x on the right side, so we can move it to the left. So 1 over 10 minus x, 20 minus x, dx dt equals to 0, 0, 1. And then we integrate both sides with respect to t. So this is the type 3. So the right side will become 0, 0, 1 t plus c. But on the left side, we have to change the shape into the partial fractions. So we do the partial fractions here. 1 over 10 minus x, 20 minus x, equals to a 10 minus x plus b 20 minus x. So I can write a times 20 minus x plus b times 10 minus x should be equals to 1. I ignore the denominators since they will be the same. Yeah. So for x equals to 10, I have 1 equals to 10a. So a is 1 over 10. For x equals to 20, I have 1 equals to negative 10b. So b equals to negative 1 over 10. So from here, I can have that this one equals to 1 over 10, 10 minus x. B is minus, so minus 1 over 10, 20 minus x. So I can change this into integral 1 over 10, 10 minus x, minus 1 over 10, 20 minus x, dt, dx. I can put the 1 over 10 out. So integral 1 over 10 minus x minus 1 over 20 minus x dx. 0, 0, 1 t plus c. And then I multiplied by 10. So negative 1 over 20 minus x dx will be equals to 0 0.1 t plus c. So on the left side, we will have ln 10 minus x over negative 1 minus ln 20 minus x over negative 1 equals to 0, 1 t plus c. So we have negative ln 10 minus x plus ln 20 minus x equals to 0, 1 t plus c. So ln minus ln is division, so I can rewrite ln 20 minus x over 10 minus x equals to 0, 1 t plus c. So remove the ln, so it's 20 minus x over 10 minus x equals to e to the power of 0, 1 t plus c. Remember that e to the power of c is another constant, so I can rewrite as a e 0.1 t. Yeah, this is equals to e 0.1 t times e to the power of c. This one called as a. So 20 minus x over 10 minus x. And then we have to find the value of a using the formula, the information given, t0, x0. So I can put it 20 over 10 equals to a e to the power of 0. Okay, I will continue here. So 2 equals to a. That means it will be 20 minus x over 10 minus x equals to 2 e 0.1t. And we will have 20 minus x equals to 20 e 0.1t minus 2x e 0.1t. And we have to collect the x, so it will be 2x e 0.1t minus x equals to 20 e 0.1t minus 20. So I can have x 2e 0.1t minus 1 equals to 20 e 0.1t minus 1. So x will be equals to 20 e 0.1t minus 1 per 2e 0.1t minus 1. And then, as usual, I have multiplied with negative e negative 0.1t, e negative 0.1t. So I can change the form into 20. This one become 1 minus e minus 0.1t over 2 minus e negative 0.1t. Yeah, don't forget, when you multiply this and this, it will be equals to 1. And this one and this one as well. Okay, so this is the formula for II. Triple I state what happens to the value of x when t becomes large. So when t goes to infinite, that means x will be equals to 20, 1 minus e to the power of negative infinite over 2 minus e negative infinite. E to the power of negative infinite is 0, approximately 0, so this is 0. So I will have x equals to 20, 1 minus 0, 2 minus 0. So it equals to 10. So the x will approach to 10.